Hey folks, Quilly here, and welcome to an update on Project MightySpud. This isn't actually episode 9, although it will end up being episode 9, probably 9 and 10, perhaps 11. Did a ton of programming on Project MightySpud today. That is all I've done all day. And I probably have 2 or 3 episodes worth of footage, I don't know. But the problem is, a lot of it is sort of like trying to work out math and equations and testing some stuff and different approaches. And I'm not going to have time to get that edited together today, unfortunately. In fact, I'm considering doing a thing that I've done before where I start over the recording from scratch now that I've resolved some of the little math issues that are mostly, need a lot of testing. By the way, what are you seeing on screen here? Well, what we're seeing on screen here is actually 25 different chunks of terrain. Each one of these is a completely different terrain chunk, all generated from this test topography where I added some numbers into the graphics so I'd be able to see it. Notice that there's the seam here, and this is also correctly balancing for projection styles. This is going to use our solution that we've talked about before by playing with rotations and doing all kinds of things like that. It's not super obvious here. Like, in a sense, you could have just sort of cut this up linearly, but that is not what's happening behind the scenes here. It should handle going around all the poles and everything really well, and yeah, sort of like warp some of these some of this terrain nonsense here, although we'll hopefully that'll be true, and we'll go into some more testing. It runs fast in engine. It does take a few seconds to generate here, probably, I don't know, 5-10 seconds. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There we go. Now that's with 25 chunks. Probably we're just going to be going with 9 chunks. I did a 5x5 here, just because I'm testing all the little possible seam combinations to make sure that they balance okay. Technically, it's not 100% seamless here. As you can see, there's like right here, for example. The reason this is happening is because I haven't actually told the terrain who their neighbors are, so they're not doing all the stitching together that they would normally do to eliminate all the seams. But as you can tell, the terrain is lining up properly. Here's the craters, for example. It should be okay anyway. And more testing will come and demonstrate if that is true. Hopefully I've done all the math correctly. But a lot of work has gone into the file. There's a little bit more cleaning up that I want to do. I've got some hard-coded numbers in here for the testing. But yeah, a whole bunch of things going in there. There's also a really ugly function inside of. So basically, I've split the scripts here. The dynamic terrain master generates all the other terrain chunks, and then there's terrain chunks, which is very similar to the code we had before. But I am currently having to write like this sort of if statement here to deal with all these cases where you have something like you have your terrain chunk, right? So we have our terrain, which is going to be square. And each corner basically has a pair of not a pair of coordinates, as a coordinate, a 2D coordinate, a vector 2, describing the UV coordinates on the image map texture that it is. But what can happen is the actual seam of the texture map can go through like this, right? In this case, you get something like 0.9x over here, whereas a 0.1x over here. And that's fine. But what's a little bit different than usual, because of all the rotations and stuff that can happen, is your seam can actually find itself like this, or on any of the corners, because we're not lined up. The seam effectively represents the the zero longitude, right, the prime meridian, but there's no reason we're lined up with that. Right now, with the current map that's going on there, it's actually, well, I mean, it's not going to be as exaggerated as that, but it's still happening, because what's happening is it's doing something like this. It's mostly straight, but not exactly, and you have the one corner that goes over there, because as we get close to the poles, that is true. There's going to be this pinching. In fact, if I went right to the poles, right, it gets really small like that, and we actually might have multiple seams in there. So that's something I'm going to have to clean up and deal with better going forward. But right now, I was just happy to get to the point where it was working, and there's like so much tearing my hair out today. Literally all I've been working on this for about 7 hours today to get this going. And I'm happy with the results, although it is not foolproof. And right now, this thing here is just sort of brute forcing some of the fix on our quads, and there's no way this catches every case, and I'm sure there's a proper sort of algorithm for solving this as opposed to a bunch of ifs. There's probably some sort of mathematical approach to resolving some of these concerns, so I will be looking into that in the future. But for now, I'm just going to go ahead and I'm done for the day. Here's my update. Tomorrow I've got a live stream, and I've got something going on Thursday as well. So my schedule for actually editing those videos together and putting them online might be a bit rough. I don't know what the approach is going to be. I might re-record them, I might take the existing footage, or I might go and just do a thing where we go through all of the code as is. I'm going to put a big thing of this is not a real solution, just a bit of brute force to get the current demo going. In particular, probably doesn't deal with the seam at the poles. It does pretty okay with the seam at the prime meridian, but that's about it. So I'm going to go ahead and commit this to Git. That way it's going to be there. You guys can download this version and play with it. It'll be a little faster if we just do a 3x3 section over here. But yeah, obviously all the hard coding's got to go away, as well as a better overall solution to calculating that. For all I know, one of you guys have got that stuff figured out, and you'll send something to me. I'm not sure, a nice equation for dealing with that, but there you go. And yeah, you can see my test topography here. I put a black line right on the equator, and I used white for some numbers in here so we'd clearly see what is going on. And actually, part of the reason that I'm not going to be able to put the videos as is because I initially took a slightly different approach to this this code over here that was completely wrong. So we'll see what's happening, but I need a drink. See you next time, folks.